Hello, good day. Welcome to Mrs. Jones' science video. We're going to take a little bit more time and go over some scientific measurement things. We're going to do a real quick review over scientific notation today. So hopefully you have seen this before, and if not, get ready to learn. Before we get into that scientific notation, I just want to do a quick little plug about measurement in general. This is what we're kind of going over this unit, is measurement and experimental analysis. And so when you are doing these measurements, it is both a number and a unit. So remember that a number by itself really doesn't mean a whole lot. But once you put that number with, or that unit with it, then it's going to have some meaning. So make sure as you are measuring throughout the rest of the year, make sure that you're putting your units on everything. We'll be measuring everything, okay? It's fundamental to all the experiments that we're doing, to experimental sciences. We'll be measuring mass, we'll be measuring length, we'll be measuring temperature. There's all sorts of stuff, and that's how we gather data. So make sure that you know how to do this stuff. Now, because we are measuring in chemistry, and chemistry likes to look at atoms, atoms are very small. So sometimes we're working with very small numbers. On the other hand, sometimes we need lots of those atoms to actually do anything with, and that can be a very large number. So when we're working with these very small and very large numbers, we like to use scientific notation because it's a way of simplifying those numbers so we're not having to write 0, 0, 0, 0, 0, 0, 0. You get the point. So in scientific notation, a number is written as the product of two numbers, a base coefficient. So if this example down here, this would be the base coefficient, and then we multiply it by some power of 10. You will always multiply it by 10, and then you'll have an exponent raised to a power. Now, the rules. Yahoo! When that example that we just had was 1.5 times 10 to the 6th power, the coefficient, so this number right here, is always greater than or equal to 1 and less than 10. We are essentially moving decimal places and making it the simplest form. And in between 1 and 10 is going to be the simplest form it can get. The base here is always 10, and this exponent shows you how many decimal places the number or the decimal would need to be moved in order to make it the original number. So in this case, a 6, when we have a positive exponent here, means our number is going to become very, very positive or very large. So to make this number larger, our decimal point would have to move to the right. If this were a negative 6, that means it's going to be closer to the negative, closer to the left-hand side, like down the left-hand side of the number scale. That means that our decimal place would move to the left. So let's try a few examples. So we have this large number, and I think you can imagine that writing this number out would be kind of a pain in the butt. So this is why we use scientific notation, to make it easier. In this number, it's not in scientific notation now, so we can put it into scientific notation. So if we look at where its decimal place is right now, there it is. And if we look at what our base should be, remember our base has to be in between 1 and 10. So if we're going to move this decimal place all the way down here, we have a 1 and a 2. 1.2 is in between 1 and 10. So that is going to become our coefficient number, 1.2. Now we know that we always multiply it by 10, and so now we just need to figure out what our exponent is going to be. How many times do we have to move this decimal place? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So we know that our exponent is going to be 9. And because this is a very large number, very positive, our exponent is going to be positive. So 1.2 times 10 to the 9th would be what this number is in scientific notation. Let's try going the other way. In this one, we have 4.32 times 10 to the negative 4th. So if we were to put that in regular notation, we have a negative exponent, which means this number is going to be very small, very close to the left-hand side of the number scale, to the negatives, so it has to move to the left 4 times. So 1, 2, 3, 4. That's where our decimal point is now going to be. All these places before it are just placeholders. We can fill in with zeros. So 0.000432 would be that number written in normal notation. Kind of getting the hang of it? Okay, let's try some more. This one, again, is in scientific notation, so we're going to try and get it out of scientific notation. This time our exponent is positive. That means we're going to have to move this decimal place to make this number very positive, to the right, to make it very large. So 7 times, 1, 2, 3, 4, 5, 6, 7. That's where it will be. Fill in all of our placeholders here. We have 6 zeros, so we have 3, 3, and 6 zeros. Pretty large number. I'm glad I don't have to write that over and over again. And let's try this last one here. Okay, this one is 0.0000000000012. Again, not a number that I want to write a whole lot. This is why scientific notation is so great. Putting this into scientific notation, if we look at where the base numbers or the coefficient number is going to be, we come down the range here and we have another 1.2. Remember, our coefficient number has to be between 1 and 10. So 1.2. Now let's see how many times we have to move that decimal place to get there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 times. So we're going to move it, multiply it by our base of 10, coefficient of 11. Now let's figure out if this number is going to be positive or negative. If we look at this number, we had to move it to the right, and this number is very, very small, very close to the negative side of the number scale. So it's going to be a negative 11. Kind of got the hang of it? Don't worry, we'll do a little more practice in class if you're not quite getting it. But for now, I will sign off and I will see you in class.